S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult concepts made easy. Study anywhere, anytime.
Hello everyone, now we'll be learning power series and convergence of power series. Till now we haven't done this type of series. We discussed so many series, but this series is somehow particular because it has the convergence. To check the convergence, we have some interesting concept in this series. Why? Because it has wide range of convergence. So let's understand this topic in this lecture. Welcome to S. Chand Academy. I am Dr. Seema Dhakran. To study the power series and convergence of power series in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. So let's understand what type of power series this power series is basically, and how to check the convergence and why the convergence part is really different what we have done in the last lectures. So what is a power series? Anyhow, it seems like that it has powers. It is true that it will the terms will be of the type that you can write the terms in some power form. How the power form, how the series will look like? Let's start with definition. A series of the form summation an xn. I am just expressing it, and there is a change also. I hope you will notice that. Let me just write first the terms. So it is a0 x0, a1 x1. I am just varying the n value. So this series is this a0 plus a1 x. Till now I was just starting my n from 1 to infinity. If you observed in the last lectures, I was just starting my n from 1, or for the particularly log series I was starting it with the value 2 because log 1 was 0. So for series, power series, if you are starting with n from 0 to infinity and it is in this power kind of form, a series of the form is called power series. If power series where a0, a1, a2 and so on are the coefficients and real coefficients, you can say, are the real coefficients. Real means real numbers, and the x is a real number. Now what are the important facts? Because if it is a series, we again look for the convergence of this type of series, which is power series. So some facts about power series. Number 1, basically the series is, so we have this as power series, n from 0 to infinity, power series. This power series is convergent always for x equal to 0. कहने का मतलब है x 0 के लिए हमेशा converge करती है. There is no condition at all. 101% it will be converging if the series is not convergent other than 0. Suppose for x equal to 0 it will 100% converge, but in case you got to know that for x not equal other than x 0 it is not converging. So the series, if the series is not convergent for other than x equal to 0, we say the series is nowhere convergent. So this is the term we use, nowhere convergent. For x equal to 0, it will 100% converge, but in case there is no other point for which this series is convergent, in such a case you call that series as nowhere convergent. Now the second point, and how to check that, for that we will be doing the test just after the facts. So the second point is, if the power series converges for all x, for all values of x, it means जितनी भी आप real values ले रहे हो, it is converging for all real values of x, then we say that the power series is converging everywhere. Power series is converging everywhere. Now the third point, it's not that other than x 0 it is not convergent. These two, other than these two situations, there is another situation, and that is number 3, if the power series converges for particularly some values of x, then we call that as region of convergence. इसका मतलब जितने पोर्शन में वो कन्वर्ज कर रही है उसको हम बोलेंगे कि ये इसका रीजन है, रीजन ऑफ कन्वर्जेंस. सो नोवेयर कन्वर्जेंस, एवरीवेयर कन्वर्जेंट, देन there is a region, particular region. It could be that the series just converge only for mod x less than 1. It means it has just this much region for convergence. Now, so let's start with now another important thing, because if it is converging everywhere, it is converging, not converging other than x equal to 0, how you will be figuring out? We have region of convergence, it means radius of convergence formula we have. So let's understand, or so the next important term related to power series is radius of convergence. So radius of convergence, let summation an xn be the power series. I'll start with the definition first. रेडियस का मीनिंग आपको पता ही है कि रेडियस मीन्स कि वो आपके सर्कुलर रेडियस जो टर्म आती है वो सर्कल के लिए हम यूज़ करते हैं, या स्फीयर के लिए इफ़ इट इज़ इन स्पेस. यहाँ पे रेडियस का मीनिंग है कि आपको एक रीजन मिलेगा विद रिस्पेक्ट टू दैट रेडियस, उसमें आपकी सीरीज कन्वर्ज करेगी अगर ये इस रेडियस से भी कनेक्शन है. सो आई विल एक्सप्लेन, बट लेट मी जस्ट राइट द डेफिनेशन फर्स्ट. सो लेट समेशन बी द पावर सीरीज, देन आर इक्वल टू, there are two formulas for this, one upon this is one formula, then the other is this. It means आपके पास एक पावर सीरीज अगर है, just see the nth term coefficient only. xn means the nth term, आप उसके कोफिशिएंट को सिर्फ देखोगे, and then whichever formula you find comfortable or applicable. कहने का मतलब है if this term, this nth term is in power form, apply this formula. If it is not in power form, then this is the only formula which is applicable. By these two formulas you will be able to find out the radius of convergence. अब यहाँ से कैसे conclude करेंगे उन तीनों points को? So कैसे conclude करोगे? If r is 0 suppose, इसका मतलब radius of convergence क्या है आपकी? 0. It means the series is nowhere convergent. क्योंकि r is 0, it means कोई region नहीं है. The series is nowhere convergent. The series is nowhere convergent. Nowhere में आपका x equal to 0 understood है कि वहाँ पे converge करेगी ही, लेकिन उसके अलावा कहीं पे converge नहीं कर रही है. And this r is only indicating that. Suppose आपका r की value infinity आई, then the series Infinity means there is no bound, there is no region, matlab it's just unlimited. So the series is everywhere convergent. And now the last point is, suppose particularly आपकी R की value कुछ आती है, particularly any value, suppose R is 1. In this case you will say कि आपका जो series है ना वो mod x1 के लिए convergent है for sure, and for this it is divergent. ठीक है, लेकिन particularly आप x equal to 1 के लिए you will check because there is no, मतलब उसके लिए कोई condition नहीं, वो आप separately check करोगे. It might goes into it might be two, there might be two cases, एक divergent का भी हो सकता है और convergent का, वो आपको देखना पड़ता है, but that is separately you do and you check. So this is how the radius of convergence is defined. Examples based on power series and radius of convergence are will be taking just after the break.
Hi, I'm Manika and you're watching S. Chand Academy. I'll be discussing the topics like carbohydrates, amino acids, peptides, proteins and many other topics related to BSc program. For more such lecture, you can stay tuned to our channel and subscribe to our videos so that you get more and more info about our upcoming lectures. You can also refer to our previous lectures on the related topics. Stay tuned, stay focused because it may help you in your competitive exams also and preparation of the other topics also related to your courses. Thank you.
Welcome back to S. Chand Academy. So before going to the break, we understood what is a power series and what basically how to check the convergence. Only formula we did. Now we'll be just doing examples based on convergence using the radius of convergence concept. So first example, check the convergence of the following power series and find their region of convergence. If it is the question is about region of convergence, it means we have to find, anyhow for a power series we always calculate the radius of convergence. In short we write ROC, that is radius of convergence. So two examples we will be doing, e to the power x, then the second is x upon 1.3 x square 2.4 and so on. There is a pattern. Now I have written only e to the power x. So how and why it is a power series? In Taylor series concept we did, Taylor and Maclaurin if you remember, we did the expansion and we wrote the Maclaurin series for x equal to 0 for e to the power x function. So in case you are given only e to the power x, you should remember the Maclaurin series series of e to the power x. So this is the series. You can write now solution. E to the power x can be written as, you just see the pattern in the terms. What will be the nth term? It will be xn upon n factorial. It means in summation form we can write it in this form. So now the question arises for convergence. Here there is one more important concept you can even observe, a function connection with series. A function connection with series, it means function convergence, and convergence is totally connected to series convergence. If this series is convergent, this function will also be convergent, or in terms of functions we say it is continuous. Now this is the series. It means I can compare it like this. So what is an? Where an is 1 upon n factorial. So I will apply which formula I should apply? Not the power formula because there is no power in the nth term. So we find radius of convergence, that is ROC, and the formula which we will be using is this one, an upon an plus 1. So my an is 1 upon n factorial what is my an plus 1? Obviously replace n by n plus 1 factorial. Take the reverse. Just reverse it and see the limit. So, it will be n plus 1 factorial upon n factorial. So, it means this is simply n plus 1 into n factorial, and simply it is tending to, it is infinity, you can say. Now, the observation is radius of convergence infinity means this e to the power x function, or you can say the power series of e to the power x. The radius of convergence is infinity. It means this series, the given series e to the power x equal to summation xn upon n factorial is convergent everywhere. So, this is the example where the series which is converging everywhere, because the the radius of convergence is coming out to be infinity. Now, see the second question, or now in this case there is no need to check x0, because for x0 it will converge. There is no condition or there is no other checking for particular point, because infinity is just fulfilling the convergence portion. So, it means radius of convergence in infinity, it means there is like everywhere convergence is existing for particular case. So, in second example, see the pattern first, x, x square, x cube, 1.324. So, if you see the pattern, the nth term will be, because x powers are continuous. So, x, x square, x cube. So, in nth term you will find xn. Now, this is 1, then 2, then 3. So, it will also be n. Now, see the third one. This is 3. When you are substituting n1, you are getting 3. So, what should be the first term? N plus 2. Because जब आप n को 1 डालोगे, you should get 3. And जब आप n को 2 डाल रहे हो, you are getting 4. So, it means nth term is, so we have summation un. Now, I can write it in this form. My series is this. Coming to the point ROC, it means we find radius of convergence, totally depending on radius of convergence, the area and nowhere and everywhere convergence. So, my un is, my nth term is this. Here also there is no power, so I will be applying the second formula, which is without power. So, now limit n tending to infinity un upon un plus 1, just and you know that if it is in un plus 1 is in the denominator, this term will get reversed. So, I am writing it this way. It is infinity, and in numerator denominator we have n. Remove n by taking it common. When you will take it common, you will get 1 n from here, so n square, then 1 plus 1 by n, then 1 plus 3 by n, then n square and 1 plus 2 by n. So, what you are getting exactly when you are tending the limit n tending to infinity is 1, this is 0, 0, 0, because 1 by infinity is 0, ultimately you are getting as 1. Now, radius of convergence is coming out to be 1. What does it mean? It means that this given series is convergent for mod x less than 1, and divergent, it means this is understood now कि वो mod इसके लिए converge करेगी for sure. This is the assurance we get by radius of convergence. So, mod x less than 1 convergent, mod x greater than 1 convergent. What about when your x is 1? What about when your x is 1? So, let us discuss that case also. If x is 1, your series will look like, if your x is 1, then the series will look like this. 1, 3, this was the series, then it was 4 and then 5 and so on. मैंने x को 1 substitute किया है. आप दिस इज नॉट पावर सीरीज एवरीवन, दिस इज नॉट पावर सीरीज. सो यानी आप यहाँ पे अब कोई रेडियस ऑफ कन्वर्जेंस कॉन्सेप्ट नहीं लगाओगे. But we have number like we have test and we have comparison test, we have root test, ratio test. Let's see which will be applicable. So what is my un? We have already done, only x we have substituted as 1. So this is my un. What I do, I just compare it because comparison is easy. इसमें नीचे कितने n है देखो आप, comparison test apply कर रहे हैं. फॉर पर्टिकुलर सीरीज आपको बताया भी था, ऐसी सीरीज के लिए बेटर आप सेकेंड कंपैरिजन टेस्ट लगाओ. सो यहाँ पे अगर आप Vn को इसको कंपेयर करो 1/n² से, बिकॉज नीचे आपके 2n है, उन्हीं को रिमूव करना है. दिस इज हाउ यू टेक योर Vn. टेक द लिमिट un अपॉन Vn. सो आपके पास बिकॉज Vn इन द डिनोमिनेटर, टेक इट अप n+2 लिमिट अप्लाई. So you will get it as limit n tending to infinity n square 1 plus 2 by n. This is coming out to be 1. It is finite. You remember the second comparison test. Second comparison test says कि अगर आपके पास एक सीरीज है उसको आप किसी से कंपेयर करोगे, you choose the series very wisely कि आप जैसे यहाँ पे n² है, you are taking it n² because n² will get cancelled. It is coming out to be 1. It is non-zero. It is non-zero, finite, and according to the second comparison test, both the series will converge and diverge together. Converge and diverge together. तो इट मीन्स एक सीरीज का बिहेवियर आपको चेक करना है एंड द अदर विल कन्वर्ज और डाइवर्ज ऑटोमेटिकली. दिस सीरीज इज कन्वर्जेंट बाय पी टेस्ट, सॉरी बाय पी सीरीज कॉन्सेप्ट एज पी इज greater than 1. So automatically summation un will be convergent. So final conclusion is that the given series, final conclusion is that the given series is convergent for mod x. Now I can put this equal sign, and divergent for mod x greater than 1. This is the final conclusion because for x equal to 1 also we have checked, and this is how the power series convergence is totally depending on radius of convergence concept. So one more example based on power series radius of convergence concept, and the example is, so example, clearly this is a power series. Let's check the convergence. So for the solution we have, see the nth term, this is this. Now what will be un plus 1? It will be n plus 1 upon n plus 2. So taking the limit, because radius of convergence we have as un upon un plus 1. So n upon n plus 1, just reverse it. So finally, and just don't make it a square, just take out n common because infinity you want to remove. So n 1 plus 2 by n, then n 1 plus 1 by n square I will write, and 1 plus 1 by n. So cancel it. Now you just see again when you tend n to infinity, this will be 0, this will be 0, this will be 0. So ultimately 1. It means radius of convergence in this case is 1. So what is the conclusion? The conclusion is that the series convergent for mod x less than 1 and divergent for mod x greater than 1. Now if I substitute x equal to 1, what will be the situation? The situation will be, the series will be this. Now I am not applying any test here because I have one important result which I did in the beginning of when I defined the series, that was just check the limit of un only. The limit of un when you are checking, it is basically coming out to be n, then n 1 plus 1 by n cancels 1. So, I state in my very first example a big result related to series convergence कि अगर आपकी जो n लिमिट un अगर इन केस नॉन ज़ीरो है, ज़ीरो नहीं है, आप स्ट्रेट अवे यू कैन से द सीरीज इज नॉट कन्वर्जेंट. So, this is very important result which I have applied here. So, series is not convergent. So, this question is done, we got to know. So, in this case what is the conclusion now this time? The series is convergent for only mod x greater than 1. So, series is convergent for mod x less than 1 and divergent for mod x greater than equal to 1. In last case we got the convergence for mod x for x equal to 1 particularly, and here this is just divergence for x equal to 1. So, in this lecture we have learned power series, radius of convergence, and in different cases where r is coming out to be 0, infinity and some particular value, and on the basis of that we can decide what is basically where the series is converging, and the series is power series particular which we have learned. So, if you want to study power series and convergence of power series concept in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. Don't forget to like, share and subscribe the S. Chand Academy. Don't forget to press the bell icon for the future updates. Thank you. Stay connected. Stay tuned.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.